Hello student. In last lecture, discuss the definition of beta function and gamma function, and also discuss the symmetric properties for beta function. And it is beta of p comma q is equal to beta of q comma p. Now in second lecture, first theorem prove that beta of p comma q is equal to 2 times integration 0 to pi by 2 sin theta raised to 2p minus 1 into cos theta raised to 2q minus 1 d theta. This theorem is very most IMP. Now to prove that. Prove uh, in left hand side is beta function, in right hand side is form of integration, and in trigonometry form. Uh, we know that we know that beta of p comma q is equal to integration 0 to 1 x raised to p minus 1 into 1 minus x raised to q minus 1 dx. This is a definition of beta function. આ ડેફિનેશન આપણે યુઝ કરીને આ થિયરમ આપણે પ્રૂવ કરવાનો છે. લિમિટમાં ચેન્જ છે, એના ઉપર આપણે અત્યારે ફોકસ કરશું નહીં. પહેલા એ વસ્તુ વિચારી તે એક્સ ઇક્વલ ટુ શું સપોઝ કરો. ચલો, હિયર એક્સ રેસ ટુ પી માઇનસ 1 and here sin theta raised to 2p minus 1. અહીંથી ખ્યાલ આવે છે કે આ બંને ઉપરથી કંઈક આપણે સપોઝ કરશું. આપણે રફોર્સ જોઈએ પહેલા. ચલો, હિયર x raised to p minus 1 and here sin theta raised to 2p minus 1. Here sin theta raised to 2p minus 1. Here base is x and here base is sin. That means તમારી પાસે જે x છે એની જગ્યાએ શું જોઈએ છે? sin. તો સપોઝ આવું કરી શકાય, x equal to sin theta. Now for power. Here power is p minus 1 and here power is 2p minus 1. Here minus 1, here minus 1, no problem. Here power is p. એની જગ્યાએ શું જોઈએ છે? આપણે 2p જોઈએ છે. એટલે here p, here 2p. તો I take only 2. That means x equal to sin theta square. જો આવું આપણે સપોઝ કરી તો શું આવું ફોર્મ બનશે? ચેક કરી. જો આવું સપોઝ કરવામાં આવે એનું ડેરિવેટિવ લઈ dx equal to 2 sin theta પાવરનું 2 sin theta, સાઇનનું રિપીટ into cos theta and d theta. હવે જરા x equal to sin square છે એને આમાં તમે વેલ્યુ પુટ કરશો, સોરી ઈયર, તો એ શું થશે? sin square theta raised to p minus 1. હવે જોવો જોઈએ sin square raised to p minus છે એટલે પાવરનો પાવર એટલે મલ્ટિપ્લિકેશન sin raised to 2p minus 2 થશે sin theta raised to 2p minus 2 અને બીજા એક અહીંયાથી શું આવે છે? sin એટલે into sin theta. Here power is 1. તો 1 આની સાથે કેન્સલ થશે એટલે -2 ની જગ્યાએ શું થઈ જશે? 1. એટલે તમે જો x equal to sin square આવું સપોઝ કરશો તો આમાંથી આવું ફોર્મ બની શકશે. now suppose x equal to sine theta square. Now take differentiation in left hand side with respect to x and also differentiation in right hand side with respect to theta is dx and it is 2 sin theta into cos theta into d theta. चलो complete. Okay, means dx is 2 sin into cos d theta. Now change the limit. We have all the limit is x equal to 0 to x equal to 1, x equal to 0 to x equal to 1. Now find new limit. How to find new limit? Put x equal to 0 in our supposition. Put x equal to 0 in our supposition. So here x is 0. Therefore 0 equal to sine square. Therefore 0 equal to sine. Therefore theta equal to sine inverse 0 and sine inverse 0 is 0. Therefore theta equal to 0. Put x equal to 1 in our supposition. Therefore x is 1. Put x equal to 1 in our supposition and it is 1 equal to sin theta square. Take square root on both sides. Therefore 1 is equal to sin theta and 1 is written as sin pi by 2 is equal to sin theta. Therefore pi by 2 equal to theta. That means x equal to 1, then theta equal to pi by 2. So now limit is theta equal to pi by 2. So now next beta of p comma q is equal to integration 0 to 1. This is our old limit and new limit is 0 to pi by 2. Limit is 0 to pi by 2. X raised to p minus 1, but we have x is sine square. Therefore sine square raised to p minus 1 into 1 minus x, but x is sine square and it is 1 minus sine square raised to power q minus 1 dx, but your dx is 2 into sine into cos into d theta. It is 2 sine into cos d theta is equal to 2 is constant outside integration. Limit as it is 0 to pi by 2. चलो here sine square raised to p minus 1. Power of power, then multiplication both. And it is sine theta. First power is 2, then power is p minus 1. તો પાવરનો જ્યારે પાવર હશે ત્યારે આ બે શેમાં થશે મલ્ટિપ્લિકેશનમાં 2 into p minus 1 is 2p minus 2. 1 minus sine square is cos square. Cos square raised to q minus 1. 2 is here written. Now remaining sine into cos d theta is equal to 2 times integration 0 to pi by 2. चलो here base is x and here base is sine. Here also base is sine. Here power is 2p minus 2. Here no any power means power is 1. If your base is equal, then addition of power. So here sine theta raised to, here power is 2p minus 2. Here power is 1. Sum plus 1. Cos square raised to q minus 1. Here also power of power means multiplication. So here power of cos is 2q minus 2, and here power of cos is 1. Same process. Cos theta raised to 2 into q minus 2 means 2q minus 2. Here power is 1, therefore plus 1 d theta is equal to 2 times integration 0 to pi by 2 sin theta raised to 2p minus 2 plus 1. Minus 2 plus 1 is minus 1. Therefore, 2p minus 1. Same as here. Cos raised to minus 2 plus 1 is minus 1. Therefore, 2q minus 1 d theta. Chalo, now this is complete. 2 times integration 0 to pi by 2 sin raised to 2p minus 1 cos raised to 2q minus 1 d theta is our statement. Beta of p comma q is equal to 2 times integration 0 to pi by 2 sin raised to 2p minus 1 cos theta raised to 2q minus 1 d theta, and this is your complete. Here we done beta of p comma q, here also beta of p comma q, here also beta of p comma q, and this is as the proof. Now next theorem. Prove that beta of p comma q is equal to integration 0 to infinite x raised to p minus 1 divided by 1 plus x raised to p plus q dx. This is also very much IMP. Uh, First, using definition of beta function, I've written we know that beta of p comma q is equal to integration 0 to 1 x raised to p minus 1 into 1 minus x raised to q minus 1 dx. This is our definition of beta function. ચલો વિદ્યાર્થી મિત્રો, આપણે અહીં બીટા ઇઝ ઇક્વલ ટુ આવું કંઈક આપણે પ્રૂવ કરવાનું છે. ઇન રાઇટ હેન્ડ સાઇડ લિમિટ ઇઝ 0 to 1, જે આપણી પાસે બીટા ફંક્શનમાં છે એની જગ્યાએ શું જોઈએ છે 0 to ઇન્ફાઇનાઇટ. આપણે જે કાંઈ સપોઝ કરશું એ લિમિટમાં અત્યારે આપણે કાંઈ વિચારશું નહીં. તો શું ચેન્જીસ છે? આપણે જે સ્ટેટમેન્ટ આપેલું છે એનું આવું લખી શકો. થોડુંક રફ વર્ક કરીએ આપણે. સ્ટેટમેન્ટ ઇઝ 0 to infinite x raised to p minus 1 divided by 1 plus x raised to p plus q is written as x raised to p minus 1 into 1 upon 1 plus x raised to p plus q is right, is also written as integration 0 to infinite x raised to p minus 1 1 upon 1 plus x raised to p plus q is written as 1 upon 1 plus x raised to p plus q is right. આવું આપણે અહીં આપેલું છે, આવું આપણે પ્રૂવ કરવાનું છે ઇન ડેફિનેશન ઓફ બીટા ફંક્શન. લિમિટ ઉપર કાંઈ જ આપણે અત્યારે વિચારવાનું નથી. x રેસ ટુ p માઇનસ 1 હિયર ઓલ્સો x રેસ ટુ p માઇનસ 1. એનું મિનિંગ શું થયું? આના ઉપરથી કાંઈ આપણે વિચારી શકશું નહીં. તો આપણે શું સપોઝ કરવાનું છે? ચલો એને આપણે મૂકી દે. સેકન્ડ ટર્મ છે 1 minus x raised to q minus 1 and here 1 upon 1 plus x raised to p plus q. જો બંનેના પાવર ઉપર કોઈ આપણે ખીંચી અત્યારે કરતા નથી, ખાલી આટલું જ હોય. here base is 1 minus x and here base is 1 upon 1 plus x. એ બેને ખાલી હું કમ્પેર કરું. here base is 1 minus x and here base is 1 upon 1 plus x. આ જે બેઝ છે એ ડેફિનેશનનો બેઝ છે, અને અહીં જે છે એ આપણે પ્રૂવ કરવાનું છે. તો આ જ આપણે સપોઝ કરી લઈએ એટલે આને શું કહી દઈએ? ઇક્વલ 1 માઇનસ એક્સ ઇક્વલ ટુ 1 અપોન 1 પ્લસ એક્સ. આ જે આપણે લખીએ છીએ બંને બાજુ વેરિયેબલ સેમ છે, તો આ બાજુ આપણે વેરિયેબલ ચેન્જ કરશું. તો ફાઇનલ 1 માઇનસ એક્સ ઇક્વલ ટુ 1 અપોન 1 પ્લસ વાય. જો આવું આપણે સપોઝ કરશું તો આપણો આ થિયરમ કમ્પ્લીટ થઈ જશે. તો ડાયરેક્ટ સપોઝ 1 minus x equal to 1 upon 1 plus y. Now suppose 1 minus x equal to 1 upon 1 plus y. આ બધા એક્ઝામ્પલ તે થિયરમ બીટા ફંક્શનના, એમાં શું સપોઝ કરું એ જ મેન વસ્તુ છે. જો સપોઝ કરતા આવડી જશે તો આગળના બધા એક્ઝામ્પલ ઇઝીલી સોલ્વ થઈ શકશે. સપોઝ 1 minus x equal to 1 upon 1 plus y. Take differentiation in left hand side with respect to x. Take differentiation in right hand side with respect to y. Differentiation of 1 minus x is minus dx equal to differentiation of 1 upon 1 plus y is minus 1 upon 1 plus y square into dy. Using d upon dx of 1 upon x is equal to minus 1 upon x square. Our 12th model. Derivative of 1 upon x is minus 1 upon x square. Using this rule here, 1 upon 1 plus y is minus 1 upon 1 plus y whole square into dy. Finally, dx equal to, in left hand side negative, right hand side is also negative, negative, negative cancel out. Therefore, dx is equal to 1 upon 1 plus y whole square dy. So now change the limit. We have old limit is x equal to 0 to 1. Old limit is x equal to 0 to 1. Old limit is 0 to 1. Now find new limit. Put x equal to 0 in our supposition. So x is 0, therefore 1 minus 0 is 1. Put x equal to 0 in 1 minus x equal to 1 upon 1 plus y. X is 0, therefore 1 minus 0 is 1, equal to 1 upon 1 plus y. 1 plus y into 1 is 1 plus y equal to 1. Therefore, y equal to 0. X is 0, then y is 0. Tends to. Now x equal to 1. Put x equal to 1 in our supposition. Now put x equal to 1 in our supposition. X is 1 here. X is 1. Therefore, 1 minus 1 equal to 1 upon 1 plus y. 1 minus 1 is 0. is equal to 1 upon 1 plus y. Now take reciprocal on both sides, and it is 1 divided by 0 is equal to 1 plus y upon 1. 1 upon 0 is infinite, equal to 1 plus y upon 1 is 1 plus y. Therefore, infinite is equal to y, means y is equal to infinite. X equal to 1, then y is infinite. So clear? Now put dx 1 minus x and also limit in our definition, and it is beta of p comma q is equal to, here limit is 0 to 1 for x, but new limit is 0 to infinite. So now limit is 0 to infinite. Limit is 0 to infinite. X raised to p minus 1. But we have 1 minus x raised to 1 upon 1 plus y. Now find the x from this part. Find the x from this part. Minus x get outside. Therefore, 1 minus 1 upon 1 plus y equal to x. And it is 1 plus y into 1 is 1 plus y minus 1 divided by 1 plus y is equal to x. Plus 1 minus 1 cancel. Therefore, your x is y upon 1 plus y. So your x is y upon 1 plus y raised to p minus 1 into 1 minus x raised to q minus 1, but we have 1 minus x is 1 upon 1 plus y. It is 1 upon 1 plus y raised to power is q minus 1 dx, but we have dx is 1 upon 1 plus y whole square dy is 1 upon 1 plus y square dy. Now is equal to beta of p comma q is equal to integration 0 to infinite. Here y upon 1 plus y raised to p minus 1. Separate the power is y raised to p minus 1 divided by 1 plus y raised to p minus 1 into, here also 1 upon 1 plus y raised to q minus 1 is written as 1 upon 1 plus y raised to q minus 1 into 1 upon 1 plus y square dy. Beta of p comma q is equal to integration 0 to infinite y raised to p minus 1 into 1 into 1 is y raised to p minus 1 divided by 1 plus y raised to p minus 1 into 1 plus y raised to q minus 1 into 1 plus y whole square. Here base is equal. If your base is equal, then the sum of power. Finally, 1 plus y. Sum of power, this is p minus 1, q minus 1, 2. This p minus 1 plus second power q minus 1 plus 2 dy. Again, beta of p comma q is equal to integration 0 to infinite y raised to p minus 1 divided by 1 plus y raised to minus 1 is minus 2, and this is positive 2, cancel out 2 minus 1 minus 1, remaining power p plus q, p plus q dy. In our statement, variable is x. Variable is x. But we have variable is y. Now change the variable. Now change the variable. Here variable is y. Now y replace x. તમને અહીંયા વેરિયેબલ y આપેલો છે, આપણે વેરિયેબલ x ની જરૂર છે, તો y ની જગ્યાએ આપણે x લખી શકીએ. બીટા ઓફ p, q is equal to integration 0 to infinite x raised to p minus 1 divided by 1 plus x raised to p plus q dx. This is our hence the proof. Beta of p comma q is equal to integration 0 to infinite x raised to p minus 1 divided by 1 plus x raised to p plus q dx. Complete.